Hi guys, welcome to part 3 of the 2.7 Calculus 2023 mock exam tutorial. In this video, I will be going over part of question 2. So, question A. A function is given by the formula y equals this. Find dy over dx, the gradient function. Alright, the first thing we need to do is expand this out to a form where we can actually differentiate it properly. So, if we expand it out, x times x is x squared, x times 4 is plus 4x, then we've got negative 3 times x, negative 3x, and then negative 3 times 4 is negative 12, and we still have that plus 6 on the end, so I'll leave it out. So if we simplify this, we're going to get y equals x squared plus x minus 6. Now we can actually differentiate it, so dy over dx, or you could write it as f dash of x, doesn't matter, equals the x squared is just going to become 2x plus the x is just going to become 1 and the 6 is going to go away. So that's your final answer, and this is the achieved grade. Next question. For the function f dash of x equals 1 plus 6x squared minus 4x. This graph has an x-intercept of 1. It's not this equation. Notice how these two are different. This one's got a dash, which means it's already been differentiated, so we need to anti-differentiate it. Find the equation of the original function. So we need to differentiate this and find what the c value is, and then that will be our equation. So if I differentiate this, anti-differentiate, f of x, it's going to equal, it's going to become x, 1 becomes x, plus, add 1 to the power, divide by the power, so there'll be 2x cubed minus 2x squared plus c. Do not forget the plus c. If you forget the plus c, you'll get it all wrong. Now we're already given an x value, so we just need to plug it in to get what c is. Now also keep in mind that if x is equal to 1, our y value is going to be 0. So we have to make this whole thing equal to 0, or else we won't get it right. So 0 equals, if we plug 1 into this equation, we will get 1 plus 2, 1 cubed, minus 2, 1 squared, plus c. And if you do all of that, and you make sure you move the number to the other side, you should get c equals negative 1. So your final equation would just be f of x equals, and if we write it out in the proper form, 2x cubed minus 2x squared plus x minus 1. I've just rewritten it out in the normal form, and that this question is worth another achieved. Okay, next question. A paper dart is thrown into the air and its height above the ground in meters is modeled by, I'm just going to highlight that. It's modeled by the function this, where t is the time and seconds since the dart was thrown. Use calculus methods to find the maximum height that the dart reaches before hitting the ground. Alright, the first thing we need to do is find the time, obviously, or else we can't do anything. So we always derive this equation first, so h dash of t equals 2.5t, that will just become 2.5 minus 1, so that's just going to become t, and then that 1.375 goes away. So once we do that, remember we make things equal to 0, so 0 equals 2.5 minus t. That means negative 2.5 equals negative t. So that means t equals 2.5 seconds. So once we've found that, all we need to do is take this time value we've found and plug it back into the equation. So we'll get t is equal to 2.5. That will equal 2.5 times 2.5 minus 0.5, 2.5 squared plus 1.375. And if you do that, you should get h equals 4.5 meters. Do not forget the unit. Okay, this question is actually worth a merit. If you are able to correctly find the height, you get a merit. If you are able to find the correct time value, you get an achieved. Okay, next question. For the quartic function, this is something different. This equation, find the equation of the tangent to the curve at x equals 1. Okay, so we're dealing with these tangent things. So the first thing I'm going to do is differentiate it. F dash of x, that's going to become, remember how we differentiate fractions? We times the top number by the power, so 4 over 3 x cubed minus 2 over 3 x. And then what we do is we need to find the gradient. So when we put f dash of x, we're given this one here, 4 over 3, 1 cubed minus 2 over 3, 1. When we do that, we should get, when f is equal to 1, it equals 2/3. So our gradient, so this is m, this is our gradient. Remember, we want it in the form of y equals mx plus c. So we've got the gradient. Now, once we've got the gradient, we can find the y value. So to find y, we just have to plug this back into the original equation. So then f is 1 equals 1/3 1 4 minus 1/3 1 squared. Doing that, you should get y equals 0. Okay, because these two will cancel each other out. So now we've got this equation, and we can just plug in the values we have to get c. So 0 equals 2/3 1 plus c. So that means we'll just have 0 equals 2/3 plus c. 2/3 to the other side, it becomes negative 2/3, so c equals negative 2/3. So our equation of the tangent will just be y equals 2/3 x minus 2/3. Remember, we don't write y and x in the final answer. So if you get the final correct tangent equation, you will be awarded with a merit. For achieved, you needed to have found the correct gradient and differentiated it properly. So this would be achieved. Alright, next question. A curve y equals f of x passes through the point 0,1 and has the gradient function. Okay, this is the differentiated form. Just keep that in mind because there's that dash. Find the equation of the tangent to the function at x equals -4. So this is kind of similar to the other question, but it's just a little bit complicated now. So the first thing we're going to do is we can just find the gradient first because it's already been differentiated for us. And we plug in this x value. So f dash of -4 equals 2 -4 squared minus 3 -4 plus 1. If you put that into your calculator, when x equals -4, the gradient will be 45. So that's our m value. What we're going to do next is we are going to anti-differentiate this so we can then find our y value. So if we anti-differentiate it, dash of x, that's going to equal add 1 to the power. So that's x cubed. I think that's right. Minus, add 1 to the power, so 1.5 x squared plus x plus c. Don't forget the c. Now, what we're going to do now is we're going to find what the c value is. So the x and y. So we go 1 equals 2/3 0 cubed minus 1.5 0 squared plus 0 plus c. So all of this will, that's 0, that's 0, that's 0. So that means c just equals 1. So we'll have f of x equals 2/3 x cubed minus 1.5 x squared plus x plus 1. Alright, that's our original equation that we had. So now we're going to find the gradient. Actually, we've already done that. We're going to find the y value for this tangent. So we're just going to pop in -4 in this equation. So that's why we needed to find that c value. So if -4 equals 2/3 -4 cubed minus 1.5 -4 squared minus 4 plus 1. Okay, that will give us the y value of something like -69.667 or whatever. Yeah, 67, haha. Okay, so yep, so that's the y value for the tangent, not this y. So now we have all the information we need to find the tangent equation. So it's going to be y equals mx plus c, remember? And plugging in the values we found, so it's just going to be -69.667 equals 45 -4 plus c. 45 times -4. So that's going to simplify this. Equals -180 plus c. So we're just going to move this 180 to the other side. So it's going to be like negatives. So this -180 is going to become +180. So our c is just going to be 110.33. So our tangent equation is y equals 45x plus 110.33. And that's it. So, grades wise, if you get this final correct equation, you'll be awarded a double excellence. This is another double excellence question. You'll be awarded E7 if you have attempted to find the tangent. So, for probably getting the y value, the gradient, and the x value correct. So, E7 is probably somewhere here. Merit is the gradient found and equation of the original function. So this would be merit, and you would also need this gradient here. Okay. For achieved, it's just the gradient or the equation found. So achieved is any of them. And that's it. Question 2 done. Cheers.